you are able to see now. Okay, reliability. What is definition of reliability? In the past, I mentioned to you that reliability, quality, maintenance, all these are related. These are related. So when we are talking about reliability, okay, we are concerned about the future, okay, the future of a system or products. Okay, the probability is related to probability, okay, kebarangkalian that the system will perform or system will function, okay, in a given period of time. Okay, so we are expecting that product to be functioning to a specified intended duration in the future, okay, under the specified operating condition. For example, when you buy a computer, okay, you know that the computer is having a quality because you are buying a branded computer, which is a new brand, trusted brand. Okay, it has quality. But now the question is it reliable or not? Can I use this computer for next 5 years while I'm studying in UTM? I do not want the computer to break down after second year. Okay, so we are asking reliability. Does this computer reliable or not? And this is the question. So reliability is a function of probability. Kebarangkalian. Does it have chances to be functioning, okay, on the second year, third year, fourth year, fifth year? Okay, you may not expecting the product to be functioning after 10 years. Okay, you say, okay, it's fine, no problem. If my computer that I bought before I went to UTM, it will be broken after 10 years. You don't care so much because it's already obsolete. Okay, it's already worn out. The color also changed. So many scratches on the computer. Okay, so you have a certain expectation. Okay, period. You are expecting that computer be functioning. Period of time. Okay, you are expecting at least during your study UTM, your computer will never crash. But we have experience, lately we have experienced e-learning crash. So this is showing that unreliable. Okay? It's not 100% reliable. It doesn't crash every day, but after some time, okay, perhaps there is a need to do maintenance once in a while to avoid from crashing. Of course, there are backups and so on. So we are talking about reliability, the functioning of equipment for a specified future time in the future. How is related to quality? Quality is we are producing according to specification. If you are looking from manufacturing, we are looking for manufacturing. We say that the product has been produced according to specification. So it is a quality. It has been produced according to expectation of customer. Okay, so it is quality. Okay, satisfying customer requirement. Yeah, you are satisfied when you buy, but after you buy, can this product functioning for the next 5 years, for the next 3 years? So this is, we are referring to reliability. It is reliable. It can be used in the future. Okay, so why not we design a product which is 100% reliable forever, lifetime? Can we do that or not? Okay, somebody is waiting in the lobby. I'm sorry, I don't know why it is now. WebEx have set up, waiting. So late, they have to wait, okay, before approving. Okay, this is not my setting. They set us for us. Okay. So anybody else waiting in the lobby? I didn't know more already in. Everyone is in. Okay, my question. Why don't we design a product for lifetime functioning? Any ideas? Can you put in the chat box or you can switch on your mic? Lifetime. Can we design lifetime forever? Okay, very good. Too expensive. Okay, not possible. It's possible, but it is expensive. Okay. So we're going to have a perfect manufacturing system. We have to have high quality of our workers, highly skilled. So it's going to be expensive to produce a product which is almost perfect. Okay, all products have lifetime. Okay, a simple example, the bulb that you use in your study room. Okay, after some time it goes off. Okay, you need to replace the bulb. Okay, so if you buy a lifetime bulb which is never break down, it's going to be very expensive and also is not economical. They're not economical. Technology change. Okay, if you are still using the old one, it's functioning but it's consume a lot of energy. Better for you to change to a new one, better technology, energy saving. Okay? So that's why when we design, we must have intention how long a product can last so that we can put proper material, proper specification. So again, remember that reliability is related to functioning in the future, okay, under a certain operating condition. All right. So there are 4 elements in reliability. It has probability. Okay, it's function of probability. It is a function of satisfactory performance. Okay, satisfactory performance. Okay, so we also have another criteria. It has to be related to the time. So if you want to estimate how long that product will last, it has to be a function of time. Okay, what is probability of that particular products? Okay, probability that equal T equal to 2. Okay, it will be functioning at year 2. Okay, what is probability that it will functioning at T equal to 6, for example? Okay, so the probability will reduce as the T increase. Okay, so that's why we say specified time. Measure again the degree of system performance. Okay, used to predict the probability of surviving. Okay, without failure. Okay, number 4, the element of probability of reliability is operating condition. Okay, it will be influence. Okay, the duration of functioning. So the operating condition could be environmental factors, humidity, vibration, shock, temperature, and so on. So if you are operating your laptop in high temperature, okay, under the sun, okay, it's going to be less time, okay, functioning less time compared to if you are operating in air-conditioned room, okay, because the environment, the computer is designed to operate in a room temperature, not in a hot, sunny environment. Okay, so the condition also play a role in order for us to estimate the probability that is going to be function, or what we call it reliability. Okay? So it is related to life cycle curve, okay, or known as bathtub curve. Okay, bathtub curve. So this is a bathtub curve. Okay, the shape is like a bathtub. Okay, if you go to hotel, okay, there is a bathtub in a room. Okay, especially the old hotel, but the new one maybe sometimes they don't have anymore the bathtub. Okay, bathtub. Okay, people, take bath inside this. Okay, bathtub. The shape is bathtub. So actually, this is actually showing the life cycle curve where we have the x-axis, which is the time. Okay. So vertical axis is what we call it the probability or the failure rate. Okay, the failure rate. Okay, what is chances to fail? If you see here, as the time move on, okay, the failure rate increase. So you have a 3-phase here. 3-phase on, okay, 3-phase on this curve. Okay, there is 3 phases on this curve. So the first curve is basically we call it infant. Okay, infant mortality phase, and you have normal phase and worn out phase. Okay, 3 distant phase. In this note, they call it debugging. Debugging is this phase. Okay, debugging, or sometimes is known as infant mortality. Okay, infant. Okay, macam kanak-kanak lah, peringkat bayi. So that is infant mortality phase. The second phase, we call it chance failure. Okay, chance failure phase, and the third phase is worn out phase. This is third phase. Okay, understanding of this will help us to plan what action to be taken. Okay, while the product is being used, okay, whether the failure is at infant stage or debugging phase, or at normal phase or chance failure. This is a normal phase where you are using it in normal phase. Okay, normal failure, and this is worn out phase. Okay, worn out phase where maintenance are related. Okay, maintenance are related. So many engineering products, okay, especially for those who are working in maintenance, you are dealing with phase 3. Okay, phase 3. When you are working in design department, development department, you are dealing with phase 1. Okay, phase 1. When you are operating, you are dealing with phase 2, okay, which is the normal operating stage. Right. So this is the same graph: debugging phase, chance failure phase, and worn out phase. Okay, failure phase. So we need to know what are strategy to be used at different phase. So how do we know the distance here and here? Of course, this is depend on product by product. Okay, and this area, and normally the longest area will be the chance failure. Okay, and the last one is where the product is worn out. Okay, you need to replace some component to make it functional. So if we are having a problem of early failure, okay, maybe you buy a product, the salesman say, okay, the warranty period is 1 year. Okay, actually it is trying to cover the range, the stage of debugging. Okay, there might be some problem in manufacturing, problem in design. It is covered at this phase. If you buy a product after 2 months, 1 month, or 3 months, it failed. So it means that this product has manufacturing problem, assembly problem. It could have design problem. Okay, design is not good. Okay, it failed early. Okay, that's why we call kegagalan semasa bayi lah. Okay, this having a problem. But for a stable product, it's going to last longer. Okay, going to last longer. It's going to fail during the period what we say chance failure. Okay, chance failure. So the failure happened during this period is because of why failure happened. You see this graph, this lambda is actually failure rate. This happened, okay. Actually, the chances for failure is low. But why failure happened? Happened because wrong operating procedure. Okay, you're supposed to operate at certain speed, but you go beyond the limit. Okay, so wrong operating procedure. Okay, so when you have wrong operating procedures, okay, wrong operating procedure. Okay, for example, wrong speed or wrong setup. Okay, you're supposed to set temperature below 100 degree, but you put it 200. Okay, so it's going to fail faster. For example, a car supposed to be used. Okay, less than 110 kilometer per hour, but you run it at 200, so it's going to fail faster, okay, because it is the operating procedure exceed, okay, the normal usage, okay. So 1 out is expected, okay, every product will 1 out, okay, akan haus, akan berlakunya failure after the design, okay, the design has exceeded the targeted duration, it will be 1 out. Okay, you need to replace, for example, bearing, you need to replace the bearing. You need to change the oil. You need to change the washer. You need to change all this, especially the moving part. And the moving part, they have 1 out. Okay, so this is wear out phase. So by understanding this curve, a lot of correct decision can be made. Okay, so we know that which part of this curve the failure happened. Okay. So how to prevent failure from 1 out phase? We prevent by change the component. How to prevent failure from chance failure? By giving training. Okay, we give training to workers to operate properly. Okay, how to avoid from failure in debugging phase? By having research and development. Okay, by having a better design. Okay, this is R&D. Okay, this part can be through training. We train the workers to run the equipment in proper procedures. Okay, if no training, he run the machine wrong way, wrong setting. Okay. Okay. And how can we avoid failure? 1 out phase, we have to go and see the mechanics. Okay, go and see mechanics to replace component. Okay, if you use your car or your motorcycle, never go and see the mechanic, it's going to be a big failure. Okay, when we go and have regular service, okay, minor repair, okay, can help for the product to last longer. This is also like in a human life, in our human life, in our life, okay, there will be unfortunate that small boy die early because of failure of heart failure during birth. And then there are some adults, okay, some adults die earlier. Okay, because why? He's not following good habit, okay, doesn't manage himself. He got obesity, he got, um, so many health problems, okay. After you are aging, of course, cannot avoid lah. Okay, nobody will last forever. Okay, so this phase, people go and see doctor more regular. Okay, 1 out phase to keep, okay, the duration longer. So how we can prolong the life of products? We can attempt to prolong this line, okay, by giving maintenance, okay, by change the 1 out component. So meaning that you're extending the life of products by doing maintenance, okay, by doing maintenance. So to be on the safe side, if you buy a car second-hand, make sure that it is within this period, okay. If you buy 2,000 or 3,000 ringgit car, okay, you spend a lot of time repair, okay. You are willing to spend more time repair, or you know how to repair, you can buy this product at this age lah. Okay. All right, I think that's enough for life cycle curve. Okay. Okay, I think this part you can read. I already explained just now. Worn out phase. Okay, maintainability. Okay, maintainability. Okay, maintenance. Okay, maintenance is related to worn out phase. So it's pertain to the ease, accuracy, safety, and economic performance of maintenance action. Ability of an item to be maintained. Maintainability is design parameter. Okay, so of course it is also effect of results of design. Okay, so we have this parameter, we call it mean time between failure. And when we're talking about maintenance, we are talking about mean time between failure. Okay, when is the average? What is the average of time between failure so that we can plan our maintenance before failure happen? Okay, in failure, okay, you can have what we call it preventive maintenance or corrective maintenance. Okay, so it's quite common for mechanical engineers to work in maintenance department. Okay, maintenance department. So every organization they have maintenance. Okay, maintenance. So how can we prevent failure from happening? Okay, this is what you call it preventive maintenance. But if you wait until fail and only then you go and see a mechanics, so these are corrective maintenance. So both have pro and con. Pro and con. If we are working for JKR, for example, you are maintaining the lampu jalan, street light. Okay, which type of maintenance would you implement? You wait the street light to fail and go and change the bulb, or you do it preventive maintenance? Anyone? Please respond to the chat box. Now you are working for JKR, for example, engineer, district engineer. Okay, which type of maintenance for the light bulb that you want to implement? Will you wait for the failure or will you change before failure? Okay, change before fail. Okay, usually, okay, somebody say corrective. Okay, depend on situation. Depend on situation. If you are in charge of traffic light, okay, make sure it is changed before failure. Because if you change the bulb of traffic light and suddenly traffic light goes off, there will be accident. Okay, so and then people go and check the record when the last time the bulb for the traffic light was changed. So they found out that OJKR did not follow the maintenance procedure, and then you are can be somebody that responsible can be charged in the court. Why? Because you don't maintain the traffic light. Okay, you don't maintain traffic light because traffic light has to be functioning all the time with reliability. Okay, so if you're in charge of traffic light, change the bulb, okay, regularly according to recommended by manufacturer. Manufacturer recommend how long the bulb should be changed. Okay, every 1 year, or maybe every 6 months, depend on products. But if you are talking about change the light bulb in a heavy road, also you need to change it according to preventive schedule maintenance. Okay, so basically we can say that changing the light bulb on the street of light on the road, it should be scheduled maintenance, because if we wait until it's failure, it's going to be expensive to change the light bulb, okay, one by one, only when it's failed. Okay, you have to sell a crane, you have to rent a crane. But if you compare to your house, okay, you have a house, you have bulbs in your house, in the kitchen, in the bedroom, in toilet, okay, in living area. Okay, do you change the bulb according to schedule, or you just wait the bulb to fail and only then you change? Okay, in case of your house. How do you do that? Okay, you wait until fail. Okay, most of us do that. Okay, why? Because there is no harm if the bulb in your living area is not functioning. Okay, you just go to the shop and replace it. There will be no accident. Okay, no accident. in your house, because this is a private property. You can just wait until it's failed and then you can change it. Okay? Unless the height of the ceiling is too high, where you need to rent a crane or maybe a specialist to change it, and then only that you can say, okay, I want to change the bulb for the whole house, because you cannot do it yourself. Okay, we have to see the cost there, because frequently changing is costly. Okay, if you delay changing, also costly, because okay, if you do scheduling, changing, where you will call electrician to come, okay, and you have to pay expensive, for example, they have to come with special equipment. You say, okay, the time to change, we change all, because if we call it the technician, the electrician, one by one failure in the kitchen, you call him. And then next time, fail in the toilet, you call him again. And the failure in the living area, you call him. So it may be more costly. But if you say that, okay, I can change myself, the ceiling is not too high, so you just wait, use anti-failure. Okay? So you have to make some estimate lah, how much it will costly. Okay, so we have some variable here. We call it MTBM, is mean time between failure. Okay, mean time between maintenance. Okay, same as between failure. MTBR is mean time between replacement. Okay, so okay, frequency of maintenance for a given time is highly dependent on reliability of item. Okay, unreliable item, more frequent maintenance. Okay, as reliability increase, maintenance is reduced. Okay, unreliable system require expensive maintenance. So that's why when you in charge of any projects, before hand over to the customer, or maybe you are representing the customer, make sure all the maintenance or all the construction or the installation are done properly. If not, the customer will have headache, a lot of repair needed, okay, after handover. Okay, reliability is a function of failure. Okay, RT is reliability as a function of time. Okay, is equal to 1 minus FT. Okay, FT is failure. Okay, reliability is 1 minus failure. Okay, 1 minus failure. FT is probability system will fail by the time of T. Okay, for example, if the probability of failure is 20%, so you're going to have reliability of 80%. Okay, remember, reliability is a function of failure. Okay, reliability is a function of failure. Okay, so to understand better on reliability, of course, some knowledge of statistics is important. So, for example, your reliability as a function of time is equal to E minus T over theta. Okay, so what is T? What is theta? T is the time. Okay, we want to estimate reliability of a certain time. Okay, E is of course 2.7183. Theta mean time between failure. Okay, mean time between failure. MTBF, meaning that one failure happened, when is the next time is going to have to fail again? So this is mean time between failure. Okay, you repair here and then you use, and then going to fail again. Okay, so this mean time between failure is theta here. Okay, so we have E minus T over theta. Okay, what is theta here? Theta is lambda. Okay, lambda is failure rate. Okay, lambda is failure rate. Lambda equal to 1 over theta. What is theta? 1 over mean time between failure. Okay, so lambda is failure rate. Okay, so the formula is this one. Okay, if you want to estimate the failure of, okay, if you want to estimate the failure of any component, okay, we can use this formula. Okay, example here. Okay, we want to estimate the lambda. Lambda is number of failure divided by total operating hours. Let's say that you are given a failure in terms of percentage of failure per 1,000 hours, okay, or failure per million. So lambda is number of failure divided by operating hours. How long is the operating hours, and what is the number of failure, okay, during that operating hours. Okay, let's say 10 components were tested. You have 10 components. You want to test how long is this bulb can last. Okay, let's say you take 10 components. Yeah, you put it on the testing. Okay, measure how long it will fail. For example, component 1 fail after 75 hours. Okay, after 75 hours, you have component 1 fail. Component 2 fail after 125. Component 3 fail 130. Component 4 fail 325. Component 5 fail 325. Okay? So you want to know now what is mean time between failure. Okay? And 5 components have failed out of 10. Okay, you have 10, remember? After 5 to 5, 5 failed. Okay? This is failure time. And after this time, you still have 5 units still functioning. Okay, 5 units still functioning. So what is the mean time between failure for this particular component? And 5 failures, the operating hours is 385. Okay, the operating hours is 385. So what is the mean time between failure now? Okay, so we have this lambda equal to 5 failure. Okay, 5 failure. Operating hours is this one. So lambda is equal to 0.001314. Okay, that's how we calculate. And mean time between failure, remember that is just 1 over lambda. Okay. Mean time between failure. Okay. Time between failure is. Okay. Okay, we have another scenario. Okay, let's say we have a chart below showing operating time and breakdown time. Okay, let's say you're doing a study on a machine. Okay, machine is running for 22.2, and then it's down 2.5 hours, and then you make a repair and run again. Okay, and then down again. Okay, and then running again. Okay, during this period, okay, you want to know what is the time between failure. Remember, mean time between failure is the average. The average failure is going to happen. So how much is operating time? Operating time is, this is the green color, the green color, green color, okay, green color, green color. This is operating time, which is 136.9. Okay, operating time is 136.9. And then we have how many failure? 1 failure, 2 failure, 3 failure, 4 failure. Okay, 4 failure during this period. Okay, 4 failure divided by the operating times. So the lambda, the failure rate, lambda is failure rate is 0.2922. So what is mean time between failure, which is 1 over lambda. So the mean time between failure is 34.22 hours. Okay, so we can expect there will be 1 failure on average between this interval. Okay, 24.22. So now what is the probability? Okay, what is the system reliability? Okay, for 20 hours. Let's say you want to know probability of this component to be functioning after within 20 hours. Okay, so we have this formula R equal to minus, remember T over theta, which is minus, we have lambda. Okay, remember lambda. Okay, mean time between failure. So this lambda, we can change it, okay, to make it lambda T. Okay, T lambda T. So we know the lambda. Okay, from here we know mean between failure. Okay, this one, we know this. So this come to here. Okay, 20 hours. So the reliability of this equipment for 20 hours is 55%. Okay, 55%. Okay, so if we change this, let's say what is reliability for 40 hours? Okay, of course this value will be reduced. So what I'm giving here or explaining here is some basics of reliability lah. At least you pernah dengar reliability. Okay, how do we improve reliability in design stage? Okay, as a design engineer, you want to know how can I improve reliability of products? Okay, you can use what we call it serial design or parallel design. Okay, where you can have a backup. Okay, so some equipment have a backup component. One component fail, the other one will take over. Okay, so this is when we improve in design. So we say this is a serial design, okay, serial network. Okay, if you link all the component, it's going to be in the series. So what is the reliability of this series? Is given by this formula. Okay, very simple formula. Reliability of the system is equal to reliability of component A, reliability of component B, reliability of component C. Okay. Okay, I would like to ask you, do you have class now? Can I have another 10 minutes? Hello, can you respond to the chat box? I need 10 more minutes to finish this. Can or not? All right, can, huh? All right. Okay, so I'm not sure whether you have studied somewhere or not on reliability. Have you studied reliability somewhere? If not, I can make it, can shortcut. Yes or no? Have you studied reliability somewhere? Can you respond? Have you learned reliability somewhere? Can somebody respond to me? The chat box? No, you don't have any background on reliability. Okay, so I think it's useful to understand, even it's a general concept. Okay. Okay, so if you have, let's say, a bicycle, you have a bicycle, you have a tire. Okay. You have a tire. The tire is connected to maybe the chain. Okay, you have what do you call this? Pocket or something like that. You know, the tire is connected to the chain, and the chain is connected to pengayuh. Tu dia panggil apa lah? Pedal. Not the pedal. Pengayuh apa yang basikal punya tu? Okay. So all these are, we can say it is designed in terms of series. If the chain broken, okay, the whole bicycle cannot be used. If the tire punctured, the whole bicycle cannot be used. If pengayuh also broken, cannot use. So they are arranged in serial. Okay, in serial. So how much reliability? The reliability of bicycle depend on reliability of tire, reliability of the chain, reliability of pengayuh tadi, and many other components in the bicycle. Okay, there are so many others. Okay, if you look at some design, for example, basikal kanak-kanak, okay, the child bicycle, basikal kanak-kanak, they have 3 tires. Okay, 3 tires. Okay, satu tayar sini, satu tayar sini. Okay, mungkin kat depan pun ada tayar lagi. Okay, saya tak pandai sangat lukis but anyway I just put the concept Okay. Okay, so for a small child, okay, there is another tire kat sini. Okay, there is another tire to prevent dia daripada jatuh lah. So all these are basically is to give reliability of while a small child is using the bike. Okay, so you see that this is a backup. This is also backup. So this is to increase reliability. Okay, if you observe a trailer, for example, okay, trailer has so many tires. Okay, if you see your car is only 4 tires, but a trailer have so many tires. Same also for the bus. Okay, at the back of the bus, you can have 2 tire at the back, 1 tire broken. Okay, for a trailer, the other tire can take over. Okay, those are backup. This is using the concept of parallel, okay, parallel design. So especially in aircraft, for example, which is require high safety, they have backup, okay, backup, engine and so on. Okay, for the serial, okay, this is the formula that we can use for the serial. The same as what we have seen, but now it is expressed in terms of exponent. Okay, this is just example. Like you can calculate this, what is reliability of serial. Okay, this is parallel. Okay, what happens is in parallel, if this fail, the system still functioning. Okay, still functioning, no problem. Okay, let's say you have, you have 3 engines. Okay, so actually you just need only 1 engine, but if 1 engine fail, this one is still operating. So your aircraft is still moving. Especially aeroplane has very high reliability and many backup, okay, parallel system. Okay, that's why you see that normally an aircraft, there will be no failure when it is flying. What problem is aircraft is down is perhaps due to weather condition, or it could be during takeoff or during landing. But when it's on the air, we rarely hear that it is a failure, because if one failure, the other system will take over. Failure still happen. Okay, for example, take off, there will be explosion. Okay, perhaps that was not proper maintenance. Somebody bak kacau kata. Okay, during touchdown. Okay, perhaps something is not maintained properly. Landing gear not functioning. Okay, so but most of the system in the aircraft, they have backup. Okay, backup. So backup is done through parallel design. Okay, so how do we calculate the reliability? So this reliability of a backup system, if you have 2 components, we know that reliability of system is failure. This is showing in terms of failure. This is a failure. Failure of system T equal to failure of A and B. And remember that a failure is coming from 1 minus the reliability. Okay, 1 minus reliability. So if you want to know what is reliability of this parallel system, okay, so it's going to be 1 minus failure of the system. Okay, this is reliability of system. Reliability system is given by this. Okay, so it's coming from this one. Okay, so when we have a parallel system, okay, reliability is high. Okay, so if component A and B are constant failure rate meaning that we can use this formula. We can use this formula. This is for constant. This formula is for constant failure rate. Remember, constant failure rate is happening, okay, at this stage in the middle. Okay, this is constant failure rate. Okay, constant failure. So if failure is, we want to estimate failure during this period, this is the formula that we use. Okay. E, okay, lambda T, yeah. Okay. I think there is a minus, right? Minus. Okay, minus. Okay. So this is expressed in terms of 1 minus lambda, 1 minus lambda, which is, okay, want to calculate the reliability of system during that period of time. Okay, let's see example there. Okay, so if you have parallel system like this, okay, so reliability of system, okay, reliability of system is given by this one. Okay, reliability is equal 1 minus failure, FA is 1 minus RA, FB is 1 minus RB, FC is 1 minus RC. Okay, so reliability of system is 1 minus RA is meaning that we minus the failure. So if the component ABC are identical, then the reliability is, if it's identical, it's exactly the same. So the reliability of that system is given by this. Okay. We can also use a combined system. Okay, we can also use a combined system. Many systems have combined system. You can have component A here, this is serial, and this is parallel. Okay, so before you can solve this, you need to solve this parallel first, and then after that, you're going to have A multiplied by B. Okay, you're going to have reliability of A, then another reliability of subsystem B and C. Okay, so this one is you have to solve this. What is reliability of this part? After getting that reliability, you just multiply reliability of A, reliability of A, multiply by reliability of B and C. Okay, so this is reliability of this part, and this part is reliability of the parallel system. Okay, the parallel system. So in between this is just multiply. But we need to solve this part parallel first. So this is useful, especially when you involve in design. You want to decide which component to be put as parallel, which component that no need to have parallel. If parallel, how many components? Normally we use as a backup a cheap component. Don't put both are expensive, okay, because it's costly. Okay, lower reliability component can be used as a backup. Of course, not too low, so we don't want that when this failure, this one is too low reliability and also not functioning. You don't want that. Then make sure this is a high reliability. This one is not as good as this one, but it's also reliable. Okay, putting too much backup also very costly. You need to cut down the cost also. So this aspect of designing, okay, is important when you are developing a system. Okay, you can have combined parallel here, and this is serial. So it could be multiple tires, multiple engine, and this one is maybe a structure which is most likely is not going to fail, and this could be maybe some motors, The overall system will have normally the combination of these. I think that's all on this reliability. Okay. All right. I think I need to see you again before your final. Can we set a date when I should, we can meet again? Or do you need to see me again or no need for the final? Hello? Can anyone suggest when should? Okay, for your information, next semester I will no longer in UTM. This is my last semester serving UTM. After that, I will retire from UTM. So hopefully I can see you again before this is my last semester. Okay, can we set a date?
Final berapa bulan Doktor?
Tak silap saya dalam belas-belas kan? Anyone remember the date? Okay, let me check my calendar. I think dalam belas-belas lah. It's going to be February. Ada 19 lah. Somebody kata 19. Is it correct? Yes, 19. 19 February, but it's going to be too late kalau kita nak buat 19. Kalau boleh early of February lah, you have enough time. Okay, somebody kata next week. Next week, I think there will be Chinese New Year kan? Next week. Today is 26 already. Okay, next week. Okay, after Chinese New Year, okay nak? After 6 lah, after 6. Boleh tak? Kalau dalam 8 hari bulan boleh tak? Hello, can I suggest 8 hari bulan? Tentatively, February. I see you again. Boleh tak? Alright, so tentatively 8 February. You have test or not on 8? I put it tentatively, we can put it at 10. And for the test, or 10 ada test. Mana lah, okay lah kau. 10 Feb start test, okay. Okay, 8 Februari lah, tentatively. Kenapa pula on weekend? 12 ada test. 8 tak ada test kan? We just need about, I think the most for 2 hours lah. I can, so 8 Februari ada test. We cannot put it 17, somebody kata 17. Tak boleh, 17 too late. Okay, do you want it on, okay, if I can extend this, can be on 11? Okay, your test is 19 tadi kan? Okay, can I put it 11? Februari, boleh tak? Okay, 11 February. Okay, 11 February. This is Friday, Oh, it is Friday, so I have to make it early, So can we have around 9? Oh, ada nak buat 7 pula. 7 tak boleh, I have PSM. Oh, ada vibration test. So macam mana ni? 8. 9 tak boleh, 9. Februari. Okay, 7 tak boleh. I'm full. 7 I'm full. Because there's PSM. Got paper also, 9. Okay. 10, macam mana 10? 10 Februari. Okay, before 8. Bulan after that final. Oh, not what? Before 8. Okay. Okay. Okay, somebody cadang before 8. Okay, before 8. So when it should be then? Before 8. 7, 6. Okay, how about 5 hari bulan? 5 Sunday 5. 5 hari bulan, no. 5 is Saturday lah. 5 February. Saturday. Okay tak? Okay. So tentatively 5 February. Okay, I put it at 10 a.m. We just need the most 4 hours a year. Okay. All right, I think that's all. And this, please everyone should attend this review on 5 February because I think that will guide you to prepare your final. So I wish you all the best in other classes and so on. Okay, so the last time I will see you for the revision is 5 February and then during the final. After that, I will finish my service in UTM. Okay, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Doktor, boleh
Yes.
nak slide tadi? Boleh tak?
Apa? Oh, slide tadi boleh. Nanti saya sharekan dalam Telegram. Okay, reminder to everyone. Please upload again your test number 2 because I don't know when the recovering of all the tests will be back again to your e-learning. As you know that on Tuesday after our test, there was a problem with e-learning. Okay, so they are recovering, but I don't know exactly when it's all will be recovered. So please upload again so that I can check it quickly for your test number 2. Okay, please. But anyway, please don't change because we're going to compare also with what you have submitted. Is everyone clear? Please upload again your test number 2 to e-learning. I have some already, but it is not in good order. It's going to take a lot of time to sort it out. Okay? If you put it in learning again, so everything is there, it will be much easier for me. All right, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doctor.
Thank you, Doktor.